Bienvenue au Centre spatial guyanais de Kourou pour le vol 141 d'Ariane Espace. Merci d'être avec nous, content d'être avec vous. Ce 4e lancement de l'année doit mettre en orbite le satellite de télécommunication Intelsat 901. J'assurerai le commentaire avec un spécialiste, Gaston Rabot, ancien coel d'Ariane Espace, qui sera donc notre expert consultant. Quant aux téléspectateurs anglophones, eh bien, ils pourront suivre un duo emmené par Henri Samuel.
Hello and welcome to Europe's spaceport here in Kourou, French Guiana for the launch of Ariane 44L, flight number 141, taking Intelsat 901 into geostationary transfer orbit. A special hello to all of you watching in Washington and Palo Alto. Myself and technical expert Bård Alertsen will be commentating this launch. But first of all, let's take a look at what's coming up in the first part of this launch broadcast. Tout de suite, un bref sommaire de la première partie de cette vidéotransmission. During this broadcast, we'll be taking you through V141's launch campaign, starting with the arrival of launcher elements by boat. You can find all the vital statistics of the satellite and launcher in the mission summary. Our news section will bring you up to date with the latest developments here at Ariane Space. We'll also be taking you on an exclusive tour of the Ariane 4 launch table. Today's profiles section shines the spotlight on two key figures of this campaign, the launch operations and production managers. And of course, we'll be guiding you through every stage of this launch, from countdown to spacecraft injection. And welcome back live from the Kourou Space Center. And as you can see, the launcher is on the pad and all the status panels are a lovely shade of green, which means no technical problems at present, Bård.
Absolutely, Henry, including the meteorological status light, which turned red on us last night due to unacceptably high winds at altitude. Michel Debrenne is tonight's range operations manager. And to his side, we have Philippe Roland, who is the Ariane Space mission director. We are sitting here with them in the Jupiter control room, some 15 kilometers from the launch pad. It's the nerve center of the launch. And if the launch is a plane, these guys can be considered as in the control tower.
Well, everyone's looking pretty calm at the moment. Of course, the people you see here are just the tip of the iceberg, of course. Many others have put a lot of hard work to get to this stage of the launch campaign. Let's find out about their contribution.
As with all Ariane launchers, the different stages of V141 arrived in Kourou harbor by boat some 6 weeks ago, traveling the last few kilometers to the vehicle assembly building by road.
First stage erection took place on April the 26th, when it was taken from its transport container and hoisted to a vertical position on the launch table. Assembly of the second stage with its single Viking engine was carried out the next day. As you can see, the second stage engine has a longer nozzle in order to optimize its performance for near vacuum conditions.
The Intelsat 901 satellite arrived on May the 2nd in a Russian Antonov cargo plane. Assembly of the 4 liquid strap-on boosters began on May 2nd and took 5 days to complete. Then came the turn of the third stage, easily recognizable in its brown thermal insulation. This is designed like a thermos flask to minimize heating of the freezing cold liquid hydrogen and oxygen propellant it will carry when full.
And last but not least, the vehicle equipment bay containing all the electronic brains of the launcher was hoisted to the top of the now 50-meter high stack.
Meanwhile, the Intelsat 901 satellite arrived in the S1 preparation building and was subjected to a series of electrical and mechanical checks in preparation for its launch. As you can see, it's a big bird, the biggest we've ever launched for Intelsat at 4.7 tons. It was put into a special transport container and taken to the S3 hazardous processing facility.
At this stage, the launch vehicle was transferred from the assembly building to the launch pad along a 1-kilometer rail track. Here at S3, Intelsat 901 was loaded with its propellants by operators protected from the corrosive fumes by astronaut-type spacesuits. It was then mated with the launch vehicle adapter and enclosed within the fairing, which is designed to protect the satellite from the elements during the early stages of the flight.
Finally, 5 days before the launch, the completed composite was taken to the pad, an operation usually done at night because it's nice and cool, hoisted to the top of the gantry and bolted onto the launch vehicle, ready for tonight's countdown.
And all systems still go here at Kourou in French Guiana. Talk us through these green status panels.
Well, they give the readiness status of the main systems involved in tonight's launch, including the base itself with logistics, safety, etc. Meteo, that was read yesterday. Of course, the spacecraft, Intelsat 901, and the launcher and the launch site.
And of course, if any of those turn red at any time up until liftoff, the countdown will be stopped and put on hold.
That's great.
Time now to catch up on the latest news here at Ariane Space. Following Edouard Perez's promotion to Senior Vice President Technical, David Concar has been appointed head of the Industrial Division, a job for which he's well prepared, having been Mr. Perez's deputy since joining Ariane Space. A high-profile exhibition showing French vision of space programs for the coming decades has been running in France's National Assembly, or Lower House of Parliament. The month-long exhibition, from April to May, also highlighted Ariane Space's full potential. During this period, Ariane Space organised a round-table discussion involving all the members of France's Space Parliamentary Group. The talks focused in particular on the continuing importance of independent access to space. Preparations are well underway here at CSG for an October launch of Envisat, the European Space Agency's environmental monitoring spacecraft, which will orbit the Earth's poles. Ariane 5 will take up the 8-ton vehicle, the heaviest payload ever launched by Ariane Space. The brand new S5 complex was unveiled to a group of international journalists here in Kourou last week. Besides doubling the spacecraft processing capacity at the European spaceport, S5 is our response to changing market requirements, both in terms of spacecraft size and campaign efficiency.
We'll now introduce you to some other key people here in the Jupiter control room tonight. Steve Hall, the Ariane Space Intelsat 901 program director. And he has with him the customer, Connie Kuhlman, DG and Chief Executive Officer of Intelsat. We also have Michel Garot, Vice President of Engineering for Intelsat. And finally, representing Space Systems Loral, which has built the Intelsat 9 series of spacecraft, and of course also 901. John Kleinberg, President of SS Loral.
Let's have a quick look at a few vital statistics of the launcher and spacecraft board. Tonight's launcher is an Ariane 44L model weighing 486 tons at liftoff. Ariane is carrying Intelsat 901, a telecommunications and television satellite built by Space Systems Loral. The 901 payload has a lifespan of 13 years and will cover North and South America, Europe, Africa and the Middle East. Tonight's launch window opens at 3:45 a.m. local time. And that launch window will last 1 hour to resolve any possible hitches that may arise.
More members of the cast of characters tonight. Jacques Rossignol, the Chief Operating Officer of Ariane Space, who is heading up the flight management group tonight, the ultimate authority for the launch. With him are Jean-Marcel Agasse and Daniel Meunier. Agasse in the picture now, Operational Director at Ariane Space.
Everyone looking pretty calm at the moment, board, but in the last few minutes, generally things get a little bit more hectic.
It is.
Time to take a quick look now at the very foundations of this launch, the Ariane 4 launch table.
No, we're not on a submarine. We're on dry land, in French Guiana, in the bowels of the Ariane 4 launch table. This Ariane 4 table, seen here in the dock next to the CDL, weighs 500 tons. When the launcher's on it empty, 550. It's one of 2 Ariane 4 tables currently in service. The table's a liaison to the launch vehicle, protecting all its equipment, holding it down, and letting it go by use of big metal hooks. Didier Saïd of Arianespace's ground systems explains.
We are behind the arms. These are the famous launch hooks. These hooks hold the launcher down till liftoff, and then let it go gradually. Inside the arm, we can see a second jack. This mechanism holds the launcher down in case of a problem at liftoff, and we have decided to stop the launch and keep the launcher on the ground.
Nous avons un plan standard de revalidation de la table. Nous allons passer 4 à 5 jours en zone de
lancement. The table undergoes standard checkouts after a launch. 4 to 5 days are spent in the launch area to check all the gauges on the table, to reset the liftoff mechanisms or solder any metallic parts that might have come loose. But nothing really major has to be done. The table doesn't suffer enormously, and roughly after 4 or 5 days in the launch area, then 3 days in the preparation area, it is ready for a launch.
Contrary to what you might think, it's not a solid, massive block of iron. It's full of holes, just like a Swiss cheese, with compartments, stairways, and cubby holes everywhere, all housing plenty of plumbing and wires to feed the launcher's vital systems. It's amazing that a launch doesn't hurt the table when you remember it's right underneath thousands of pounds of thrust and all the flames and exhaust. Not having to rebuild it from scratch each time means greater flexibility and more launch opportunities. When it's ready to roll out again, it goes like a train on a double track out to the launch pad. These tables are going to be retired after the Ariane 4 program. They've served for over 100 launches.
Well, a couple of minutes ago, at T-minus 10 minutes, we had our final weather check, which thankfully was good. Yesterday problems seem to have gone, board.
Yes, all the criteria tonight are okay. They concern mainly visibility, cloud cover, and wind speed. Wind speed, of course, was what was wrong yesterday. We had too high wind speeds and directions, for that matter, at high altitude. These things we measure with balloons, send up balloons at regular intervals during the countdown. Yesterday it wasn't good. Today it's okay.
And one of the reasons that it wasn't good is that if the wind blows in the wrong direction, of course, it could actually fall back onto the...
If we have to destroy the launcher during the flight, then the pieces could blow back onto the beach, yes.
So it's an extra safety...
It's a flight safety
measure
element.
Well, in a moment, at T-minus 6 minutes, we'll enter the final countdown or synchronized sequence, a critical stage of the launch.
Attention pour le début de la séquence synchronisée.
This is the range operations manager, Michel
à
Debrun.
-6 minutes.
And there we have it, the start of the synchronized sequence, where a whole series of final procedures and checks are carried out by 2 computers. These final operations are controlled from the launcher control room or bunker.
We are at the CDL, the launch center, which is a concrete blockhouse 1 kilometer away from the launch pad. The synchronized sequence and the control of the liftoff will take place here. The COEL is appointed for a launch campaign. In this particular case, it is called the Flight 141. His preliminary work starts in Evry, a fortnight before the start of the campaign. Then, the COEL goes to French Guiana, where he is responsible for the assembly and the commissioning of the launcher since the very first day, called D1, until the last day, called D0. His works ends a fortnight after the launch with a final report called called the level 0. The COEL works with a team of 250 people made of Ariane Espace engineers and onboard systems industrialists who are the designers of the launcher and the ground system industrialists who contributed to the design of the launch pad. This team is part of the Flight 141 campaign. Next to me is the CPAP. She will tell you what she's responsible for. The CPIPs has the responsibilities over the launch vehicle only. The CPAP must make sure that all the operations that are carried out guarantee the reliability and the flight readiness of the launcher. As a matter of fact, there are two major phases in the CPAP's work. First, a meeting held in France before the start of the campaign, which is called the Flight Readiness Review, the purpose of which is to present to the Ariane Technical Committee what was done to the launcher in France. And second, at the end of the campaign, a meeting which is called the Launch Readiness Review, the purpose of which is to present to the same technical committee the anomalies encountered during the campaign, their analysis, the corrective actions taken, and to obtain the green light from the ATC to start the filling operations and the countdown.
Well, Henry, I think we might explain the difference between what happens before and after entry into the synchronized sequence. As a matter of fact, before that point in time, Francis Pellacoeur and his team out in the blockhouse, they controlled all the operations necessary on the launcher and on the associated ground systems manually, using two computers, one controlling liquid systems and one controlling electrical systems. From 6 minutes onwards, there's too much happening, too fast for human operators to do that manually, so the computers do it automatically.
And of course, there are no human operations near the launcher from the moment that the gantry is removed, which we're seeing here in these pictures. The gantry protects the launcher, and it also gives access to it, and it's removed, what, about 5.5 hours before?
5.5 hours before launch, in preparation for the fueling of the third stage, because with liquid hydrogen and oxygen being pumped into it, you don't want to be anywhere near the place.
Fair enough. So, as you say, there are two computers now dealing with all the checks, presumably because humans are just incapable of carrying out all the procedures necessary.
It's too fast. At this point in time, they're monitoring the correct execution of all these commands and operations.
Well, here is a very important part of the final stages of before liftoff. These are the cryogenic arms we can see here that are topping up the third cryogenic stage of the launcher with liquid oxygen and hydrogen. When does this actually stop?
That lasts all the way up to very shortly before launch. And as a matter of fact, we will be seeing this picture just before liftoff, because these arms have to leave the launcher 5 seconds before ignition.
So this is the very last physical thing we'll see before we actually lift off. Obviously tension now slightly starting to mount in the control room. Let me just say that obviously this launch is the culmination, what, of 3 years' work by, well, hundreds of companies, thousands of people. I think it's fair to say it's a story of truly global dimensions. In a moment, the DDO...
Attention pour moins 1 minute.
And that was it. He's about to announce the final minute countdown.
Top à 0 moins 1 minute.
And there we are, we're into the last minute. Welcome to any latecomers around the world. Do keep your eyes on the screens. Our best wishes go to Intelsat, Space Systems L'Oréal, and everyone here in the Ariane Space team. The very best of luck for the launch of Ariane 141. We'll keep quiet now and let you enjoy the final few seconds and the liftoff.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top, allumage et décollage.
It's a truly marvellous sight aboard. It's a great symbol of man's technological achievements. How are you feeling? You've seen a few of these.
You get goosebumps every time you see that. I can't get used to it.
Just to say that the confetti-type stuff that we saw falling off the launcher at the beginning was totally normal.
That is, of course, entirely normal. These are thermal insulation panels that protect the second stage from heating before takeoff.
As the range operations manager said, all parameters are still normal. Incredible thrust to lift that amount of weight, 486 tons straight upward.
Yeah, well, with the 4 liquid boosters and the 4 engines of the first stage, this vehicle is burning a total of 2 tons of fuel per second to achieve this.
Incredible, and which means it's going extremely fast. Tell us a little bit about the indications we can see there on the screen. On the left.
You can look at the bottom of left-hand side of the screen. You have V velocity and A altitude. So you see it's already at 11 or 12 kilometers altitude and half a kilometer per second velocity.
Just saying that we're getting a tremendous rumble here in the Jupiter room, which is just the sound of the launcher.
The other interesting item to see here is the curve on the top of the screen. With the line, of course, representing the theoretical path that the launcher will take. And the little dot climbing along that is where the launcher actually is at every.
So it's right in the tracks of where it should be, in fact.
In the groove.
So this booster stage that we're in, how long does that last? We're coming to the end of it already, I think.
They burn approximately 2 minutes. And you see that little blip on the curve. That's where the boosters should normally separate.
And that will be coming up in just a few seconds.
Tous les paramètres à bord sont nominaux.
All parameters normal.
Extinction des pales.
So the boosters just burned out.
And they will now fall into the sea.
Séparation des pales.
And they have separated.
Okay, so we've got through the first bit, okay.
Now they will be destroyed. They will be blown up by pyrotechnic charges and fall in little pieces into the ocean off the coast of French Guiana.
And here's a computer simulation of the booster jettison. 4 liquid propellant boosters. Of course, the Ariane 4 is capable of taking solid or liquid boosters.
Correct.
On the curve now, we can see the next phase is the separation, SEP 1 and 2, a separation of the first and second stages, which both have a similar propellant makeup.
They both have exactly the same propellant makeup, and they actually have very similar engines. The second stage having just 1 engine, of course, but with a much longer or bigger nozzle than the first stage. This because the second stage operates in near vacuum, so you optimize the nozzle for that kind of operation.
Extinction du L220.
That's the first stage shutdown.
Et séparation du premier étage. Allumage du deuxième étage.
And the second stage is up and running.
And here we can see exactly what's happening.
Tous les paramètres sont nominaux.
All parameters still normal. So now we're at 3.3 and rising kilometers a second. What do we need to reach in terms of velocity to get a successful injection into orbit?
It's approximately 9.5 kilometers per second.
Well, the next phase that we're coming up to in just a minute is the separation of the fairing, which was protecting the spacecraft at the moment from overheating. And that should be coming up in just a second.
The fairing, of course, has protected the spacecraft from the elements of the atmosphere during the wait on the pad and during the flight from atmospheric heating. When we're now up to above 100 kilometers, there's so little atmosphere left that the heating is negligible, and we get rid of that extra mass.
And that fairing is now gone, so what is about 700 kilos?
It's about 800 kilos.
800 kilos. So we're optimizing the launcher's mass profile there.
We do not want to drag that along for any longer than absolutely necessary.
Absolutely. Well, coming up now is the second stage burnout, as we can see on the curve.
Second stage has approximately a 2-minute burn time. Pierre Moscois in the picture, the head of CSG, the launch base.
And of course, once the second stage burns out, we'll be onto the third cryogenic stage, which Cryogenic meaning cool because of the liquid hydrogen oxygen in its tank.
Very cold. Liquid oxygen at minus 170 degrees Celsius.
Extinction du deuxième étage.
That was the burnout of the second
Séparation.
stage.
Separation.
Et allumage du troisième étage.
And there we have it. Now, this third cryogenic stage board is the most advanced type of launcher engine in the world at the moment.
Well, cryogenic engines are the most difficult ones to build because of the nature of the propellants used, in them being very cold. And you need pumps that run with very high velocity. I mean, the turbo pump feeding the propellant into the engine, it runs actually at 60,000 RPM.
That is an incredible speed, isn't it? But the actual, this is a very long stage, isn't it? It lasts right up until spacecraft separation.
In the picture, Fernando Doblas, recently appointed ESA representative in French Guiana. ESA, of course, being the organization that has funded the development of the Ariane launchers.
As you just heard, we have now got acquisition from the first tracking station in Natal, Brazil. Of course, tracking stations are extremely important to help the spacecraft check its position board, but they're also important after the launch as well.
Well, they're really necessary for Terry Edwards. Terry Edwards is the Intelsat satellite mission director, and he is actually the director of Launch Services Program Management for Intelsat. Yeah, we were on the
tracking stations.
They are necessary for two main reasons. One being that for flight safety reasons, we need to be able to track the vehicle in the early stages of the flight to make sure that it doesn't go outside the allowed corridor. And of course, during the whole flight, we get telemetry data.
Right. Well, let's have a quick look at our client Intelsat.
Leadership.
Service excellence.
Clear vision.
Intelsat is shaping a bright future.
Join us.
Be part of it.
We are the world's first and foremost global satellite communications company. Our satellites are helping millions of people everywhere communicate, exchange information, and perform transactions.
All essential tools in a global economy.
Les paramètres à bord sont
Our reliability is over 99.99%.
We have the satellite expertise and a clear vision to guide us in the new millennium. Every day, we help the world keep in touch.
We bring historic events to life. Our fleet of geostationary satellites covers every country on Earth. Intelsat's connectivity is unrivaled. More than 7,000 gateway Earth stations and several million smaller antennas access our system. We link the world.
East
And west.
este y oeste. North and south.
Nord et Sud.
Developed.
And developing regions.
Wherever you are,
You're always within our reach. Whatever our customers are planning,
And wherever it's happening, we can make it a reality.
donc fin de poursuite
We help
de
broadcasters deliver world events. We connect corporate networks around the globe. We help carriers build international connections for public voice.
and data networks.
We provide backbone connections for internet providers, bypassing congestion on terrestrial networks and making the World Wide Web worldwide.
culmination du lanceur, tout est nominal à bord.
Well, one historical detail that that film, which seems to have been cut off, didn't mention board was that Intelsat were Ariane Space's very first customer back in 1983.
Trajectoire nominale.
That's correct. Intelsat is a big customer in space, very important. Arianespace has launched 60% of their satellite fleet, or put it the other way, Intelsat has entrusted Arianespace with 60% of their launches. This is the 18th satellite that we launched for Intelsat today. I think that represents a certain confidence and trust between the two companies. They share the same philosophy. We work very well with Intelsat.
And so, of course, this is the first of the new generation 9 Intelsat satellites, and Arianespace will be launching another one of those this year.
Another this year. We'll be launching in total 6 out of 7 of those. So in an 18-month period, we will be launching 6. They represent the major part of our manifest over the next year.
Well, in a moment, or quite soon, we shall be coming up to acquisition from the island of Ascension. But before we do that, let's just go back to, we were talking about tracking stations, and you were telling me the importance of them, not just during the flight, but also afterwards.
Yeah, I was going to say that we, of course, use the tracking stations to take down telemetry from the launch vehicle during the whole flight. Telemetry being measurement data from various functioning elements of the vehicle. There are about 500 measurement points on an Ariane 44L altogether.
Donc tous les paramètres à bord sont nominaux.
And of course, we use that to check that all systems have worked as they should during the whole flight.
And it also helps, of course, the spacecraft to know at any moment exactly where it is. It's got its own tracking device.
Well, the launcher itself has its own onboard...
Acquisition par ascension.
Well, okay, there we have acquisition from the island of Ascension, which you may or may not know was an important tracking station for the British some 200 years ago, actually. It was a strategic outpost for Nelson's ships. Now, of course, it's tracking a more modern form of locomotion. Let's have another look at the indications here on the screen boards.
Tout est nominal à bord.
All is nominal.
All is absolutely nominal. We are up to, as you see, 7 kilometers per second. As a matter of fact, the third stage provides practically half of the velocity, the total velocity that the vehicle requires to get into the geostationary transfer orbit on its own.
And so, explain why it is that the curve is going down here. Does this mean that we're losing altitude?
We are indeed. We are, as a matter of fact, trading altitude for velocity, using the gravity pull to aid the third stage engine in getting the velocity up. And this is a function of the optimization of the whole Ariane 4 launch.
Donc, il reste 6 minutes de propulsion.
So we have 6 minutes of propulsion left. The third stage running for approximately 13 minutes in total.
And this is not a particularly powerful stage, but it's a long burning.
That is indeed the reason why it's a long burn. It's not very high thrust, but very efficient. That's why you would tend to choose a cryo stage for the upper stage on the launch vehicle.
And of course, the Ariane 5 generation next year will be introducing a
That's a good stage.
That's a good point. The Ariane 4 upper stage engine, the HM7 cryogenic engine, will, as a matter of fact, equip a new upper stage for the Ariane 5 vehicle, which we will put into service by the middle of next year. This engine now, of course, having racked up a considerable number of successes, it's 61 in a row before tonight's flight, and I certainly hope that it will have 62 by the end of this.
Il reste 5 minutes de propulsion. On est toujours nominal sur la trajectoire.
Well, with 5 minutes to go, things still looking perfectly good. An incredible story, really, Ariane 4, of, well, both flexibility but reliability, as you were saying.
Very high reliability.
Well, here's a person who's put a lot of faith into Arianespace, Terry Edwards.
Hello, my name is Terry Edwards from Intelsat. I am Intelsat's Director of Launch Services Program Management. I'm here for the launch of the Intelsat 901 spacecraft. Our launch campaign actually began on the 2nd of May with the arrival of the spacecraft here in French Guiana, and of course now we're getting very close to launch. I'm very pleased to be working once again with the teams of Ariane Space and CSG. Over the years, we have developed a very important and close relationship. This is our 18th use of the Ariane launch vehicle. The launch that we are preparing for is the launch of Intelsat 901, which is the first spacecraft in the Intelsat 9 series. There are a total of 7 spacecraft manufactured by Space Systems Loral in the Intelsat 9 series. These spacecraft will be used to replace existing spacecraft currently in the Intelsat fleet, plus in addition provide to Intelsat customers increased communications capability at higher power. The specific role of Intelsat 901 and its orbital location is to provide high-power C-band coverage for North and South America, as well as Europe and Africa, and in addition, high-power Ku-band coverage for Europe.
We were talking about reliability before Terry came on. As we said, very high reliability, 61 flights successes in a row. A major reason why our customers choose Arianespace, I think, and we hope and we are confident that the Ariane 5 vehicle will take up that proud tradition.
Well, yes, there have been very few faults, and of course a key reason for this as well is the attention to quality, which has led to Arianespace being recently awarded the ISO 9000 quality certification. What's all that about?
ISO 9000 is the certification that we're following a certain rules and procedures of quality management.
Well, as you can see, we are now coming up to the extinction of the third stage.
Should be a little bit over 2 minutes left now.
Just a couple of minutes left. But we'll also be having an acquisition from the second last tracking station.
Il reste 2 minutes de propulsion.
In Libreville, Gabon. That announcement there that we have just 2 minutes left from the third stage. Coming up, of course, yeah, so the extinction of that stage. Talk us through what happens at that point.
Well, first of all, the third stage should stop upon determining by its own that it has reached the velocity and the proper orbit required. So it stops on command. It doesn't stop because it runs out of fuel. In normally.
theory.
And once the
acquisition Libreville.
Once the third stage engine has stopped, of course, then we're in orbit. I mean, there's no change of orbit after that point in time. After that, the stage will go into a series of maneuvers to put Intelsat 9 into the required separation attitude.
And well, we're just seeing pictures here of the acquisition from Libreville, and 1 minute left before burnout. And so you were saying there are several maneuvers that need to be done, and rather artistically called a space ballet, isn't it?
A space ballet, which in this case it's a pas de deux, because there are only two of them. We do double launches from time to time, and then you have 4 objects that need to be maneuvered.
And so what happens in this space ballet, there is also the third stage goes into spin.
The third stage, once the spacecraft has separated, will go into what we call an avoidance maneuver. So we will open a little thruster to get more distance between them.
Encore 20 secondes de propulsion.
20 seconds of propulsion left.
Extinction du H10.
That was the burnout of the third stage.
That's it. We're in orbit.
Things are looking good.
Yes.
Début de la première manœuvre d'orientation.
And here we have the first orientation procedure. What exactly? At the moment, of course, the spacecraft is still on top of the vehicle equipment bay, but in a moment it will separate. And that's a rather delicate maneuver, isn't it, Board?
It's a delicate maneuver in the sense that we have to separate the spacecraft in a very exact attitude. The separation being performed, of course, by an explosive bolt which opens the clamp band which holds the spacecraft down onto the launch vehicle. Then it separates by spring force, separation springs that are asymmetrical, so they actually impart a transverse spin to the spacecraft as it leaves the vehicle.
So there we just had the end of the
first orientation phase.
Right. And then after this separation, you were saying there will be an avoidance maneuver.
It imparts a relative velocity between the two bodies of about 0.5 meters per second. So they will slowly move apart.
Deuxième manœuvre d'orientation.
Yes.
And then the separation distance will grow quicker once the third stage goes into the avoidance maneuver.
Coming up now to the moment of truth. Separation of Intelsat from the vehicle equipment bay should be coming up in just 1 second.
Fin de manœuvre d'orientation.
Connie Coleman waiting impatiently for his spacecraft to be liberated.
Séparation Intelsat 901.
And there we have it, celebration and satisfaction after another huge success, huge sighs of relief going on there in the Jupiter control room.
Yeah, what needs to be said though is that this is the end of our workday, so to speak, but it's the beginning of Intelsat and L'Oral's activities, because now they have to acquire the spacecraft and perform a long series of maneuvers to put it into its geostationary orbit, deploy all the antennas, etc., and test the spacecraft before its entry into operation.
They're all looking pretty happy there, all the clients, and of course, the expression they say is that they're not totally relieved until they hear the baby cry. In other words, that they actually hear the satellite.
And the baby is expected to be heard crying about 20 minutes after separation.
That's rather longer than your average human, but...
Yes.
Well, in a second, we're going to get another chance to see that successful liftoff of Ariane 4. People still milling around here looking extremely relieved.
And Ariane 44L liftoff, of course, is very slow. It's the heaviest version of the vehicle. Very powerful.
And really, this Ariane 44L launch is coming to the last few Ariane launches, because we're coming to the end of of what's been quite an incredible story.
Well, this was the 13th last vehicle, so there are 12 left, and we expect the last one to be used by mid-2003. By which time there will be no more Ariane 4s. But by that time, we should have ramped up our Ariane 5 vehicles to a yearly launch rate of about 8. Although we have production and operational capacity to go beyond that if the market so should require.
Of course, this Intelsat 901, as you mentioned earlier, is the heaviest satellite that Ariane 4 has taken up. Of course, one of the reasons why Ariane 5 is so important, because it can actually take up heavier payloads.
Indeed, we already have spacecraft with masses up around 6 tons on our order books, and that, of course, is too heavy for Ariane 4. So Ariane 5 was absolutely strictly necessary to meet the market demands. Which is also the reason why we're developing the cryo upper stage version of the vehicle, which will give us yet another 3 tons more performance, to a total of 10.
Which should keep the satellite companies happy for some time to come.
We hope so. Of course, now we're waiting for all the dignitaries to get to the other side of that glass partition for the customary speeches after a successful launch.
So we had a fight. Here we have a replay of the launch here, so let's enjoy those moments once again. In just 1 second. One interesting thing, Bård, is that at the very beginning of the launch, it's as if the launcher is stuck to the pad, despite the fact that it's full blasting. That's because it's held by hooks, isn't it?
Yes, it's held by the hooks for approximately 4.5 seconds after ignition.
Allumage. Et décollage.
Surely all those watching in French Guiana have got a great view tonight in terms of pretty clear skies. Almost full moon.
Well, the meteor report just before liftoff said it was 20 kilometers visibility, so yeah, they should have had a good view of it. But again, to come back to that, the hold down, the vehicle is held down on the pad during the ignition phase to make sure that all engines are up and running correctly before you release it, because even at that stage we can still shut the thing down if something is not correct.
The 186th satellite for Ariane Spaceport there, and as Mr. Rossignol said, the 62nd success in a row. That's quite remarkable. In fact, I believe it's a world record.
Should be.
World record in terms of commercial launches, yeah. Well, to say that celebrations will continue here well into the night is just slightly superfluous, Board, because it is already late into the night.
For the second night in a row.
For the second night. Some of us a little tired here in French Guiana, but extremely happy, and I don't think too many people will be going straight to bed quite yet. It's been a pleasure working with you, Board.
Likewise. Hope we'll do it again.
I'm sure we will. And all of you watching from around the world who played a part in this mission, congratulations. And of course, we look forward to working with you again extremely soon at Ariane Space, and in fact, we know that we will be working with you again soon.
Yes. Goodbye.